Hey everyone, today we are going to finish our Riemann sum lesson. Um, we're really going to look at different ways to find Riemann sums. So far we've been looking at right endpoints, and today we're going to start off looking at left endpoints, and then we'll look at midpoints, and then we'll kind of do a quick summary about what we're doing. Okay. So let's start here at example 5. We have estimate the area between 5 plus 2x minus 0.25x squared and the x-axis using 4 rectangles with left endpoints. So that left endpoints simply means we are going to start from the left-hand side. So again, we're trying to estimate this area. We're not trying to find it exactly, just estimate it. And we're going to use 4 rectangles, and we're going to do those left endpoints. So the first thing I need to know is how wide each rectangle is going to be. We did this before, but let's do it again. So we have delta x equals 10 minus negative 2 divided by, and we want 4 rectangles, so divide by 4, which gives us 3. And we can do that in our calculator. 10 minus negative 2 divided by 4, and that gives us 3. Okay, so what I'm going to do is I'm going to start at negative 2, and I'm going to draw over 3. 1, 2, 3, and that is my first rectangle. My next rectangle, I'm going to start at 1. I'm going to go to the height of the curve, and I'm going to go over 3. 1, 2, 3, and I'm going to go down to the x-axis, and then I'm going to start at 4, and I'm going to go up to the height of the curve. I'm going to go over 3, 1, 2, 3. I'm going to go down to the curve, so I hit 7. And then my last rectangle, I'm going to start up at 7, and I'm going to go to the height of the curve. And I'm going to go over 3. 1, 2, 3. And then I am going to go down to my curve again, or not to my curve, to my x-axis. So we have these 4 rectangles. And so our area is equal to the height of my curve at negative 2 times my delta x plus the height of my curve at 1 times my delta x plus the height of my curve at 4 times my delta x plus the height of my curve at 7 times my delta x. And so what we're going to do is calculate what's the height of my curve at negative 2, which that one's 0. What's the height of my curve at 1, 4, and 7. So like we were doing in our first video, I'm going to hit y equals, and I'm going to type my curve into here. I think it's already programmed in. So 5 plus 2x minus 0.25x squared. And what I want to do is find out what is the height of my curve at negative 2, 1, 4, and 7. So my area is equal. And what I'm going to do is I'm going to hit second. I'm going to hit graph. So it brings up my table. My table is not very pretty, so I'm going to go in and fix this. I'm going to hit second window, and I'm going to start this off at negative 2, and I'm just going to have it go up by 1. So now I'm going to hit second graph. At negative 2, the height of my curve is 0. We know the width of my curve, or the change in x, is 3. Or not the width of my curve, the width of my rectangle, plus the height of my curve at 1, positive 1, is 6.75, and the width of my rectangle is 3, plus at 4, so we're going to scroll down to my x is 4, so the height of my curve is 9, and the width of my rectangle is 3, plus our last one is we want what is the height of the curve at 7, and that is 6.75, and the width of my rectangles are 3. Okay, so if we calculate it this way, we have 0 times 3 plus 6.75 times 3 plus 9 times 3 plus 6.75 times 3. And we get 67.5. So the estimate of my area is 67.5. And if I was to write this in summation notation, this would be the summation I equaling 1 to 4 of f of xi times delta x, where x1 is -2, x2 is 1, x3 is 4, and x4 is 7, and delta x is always 3. And so to kind of put this with our pictures, the height of my curve at -2 is 0, so this is this rectangle right here that I have in pink. It's not really a rectangle, it's a line. And then at f of 1, we go to the height of the curve, so that gives us the height of our rectangle. And our width is 3, so we have this rectangle. Okay. And then at 4, f of 4 gives us 9, so that's the height of our curve at 4, which gives us the height of our rectangle. And so we find the area of this rectangle. And then we did another pink one because our first one was 0. And so that f of x, or the f of 7, gives me, okay, what is the height of my curve at 7? And then we go over 3, which is at times 3, and we find this area. And then we add all of those up, and that's how we got the 67.5. All right. So the difference between using left endpoints and using right endpoints is left endpoints, we start at our lowest number and move up, where right endpoints, we start at our biggest number, so we start at 10, and we move down. Okay. So example 6 says, estimate the area between 5 plus 2x minus 0.25 x squared and the x-axis using 4 rectangles using midpoints. Okay, so here we want to use midpoints. And so we know for rectangles, when we've done this in the past, we have our delta x, so our change in x is our highest number, so 10 minus -2 all over 4, which is 3. So the width of each rectangle is going to be 3. So 1, 2, 3. So we're going to have a rectangle right here, we're going to have a rectangle right here. I'm just drawing the bases here. 1, 2, 3. 1, 2, 3. And then 1, 2, 3. So this is the base of each of my rectangles, but this time we want to use midpoints. And so really that's in the middle of our rectangle. So we're not using the left endpoint of our rectangle. We're not using the right endpoint of our rectangle. We're going right in the middle. So for this rectangle, it starts at 2 and ends at 1. Let's look at this. So we have starts at 1. Or starts at -2, ends at 1, and then we want to cut that in half. So we get -0.5. So we just add the endpoints and divide by 2. And so we get 0.5. So the height of this rectangle is whatever the height of the curve is at 0.5. And I'm going to draw 1.5 on either side. So this is my first rectangle. So I'm going to go ahead and start this formula. The area of my curve, or of the estimate of the area under the curve, is my function evaluated at -0.5 times delta x. And so that will give me the area of this rectangle right here, which is a much better estimate because I'm not including that 0. Oh, I guess I can't scribble all the way in. Okay. And then my next rectangle starts at 1 and ends at 4. So 1 plus 4 divided by 2. So I'm going to go to 2.5, and that's going to be where I evaluate this rectangle at. So at 2.5 all the way up to the curve, I'm going to go 1.5 on either side of this. And so this is the curve that I'm looking for. Or not the curve I'm looking for, the rectangle I'm looking for. So I'm going to zoom in and write this a little bit smaller. I'm going to zoom in so this all fits. So area is equal to my function evaluated at -0.5 delta x. My next rectangle was evaluated at 2.5 delta x. Then I'm going to look at my blue one. It starts at 4, ends at 7, divided by 2. So we're going to go to the curve at 5.5. Go up to the curve. Evaluate on either side. Then we're going to color this in. So this is my third rectangle. And so this is my function evaluated at 5.5 times delta x. And my last rectangle that I'm going to look at is my green one here. And so it starts at 7, ends at 10, divide that by 2. So kind of like trying the average number, the number right between them is 8.5. Go up to my curve and draw my box. And so this is my last rectangle. So plus my function evaluated at 8.5 delta x. Okay, so now I need, what are these heights? This was kind of a representation of how I built my formula. Now, what are these heights? So I'm going to go into y equals my functions there. Actually, I'm not going to do that for this one because it's a bunch of 0.5s. I'm going to click on vars, which is that red key. I'm going to go over to y vars, so I'm going to hit the over key once. And don't worry, we only have to do this once. Function, I'm going to tell it y1. Sorry about that. So we have y1. And so I'm going to evaluate the curve of negative, oops, parenthesis, negative 0.5, and that's at 3.9. So my area is 3.9 times 3. So my change in x is still 3 because the base of my rectangle is still 3 units, even though we evaluated at the midpoint. Plus, and now I want to evaluate at 2.5. So I get plus 8.4 times 3. Plus, and now I want to evaluate at 5.5. So to bring that screen back up, I'm going to hit second enter. Anytime I want to press something on my calculator, it shows up in red. So if I don't say it or I go too fast, feel free to pause the video and rewind. Scrolling back to 5, so 5.5, and we'll get 8.4 again, times 3. And then my green one, I'm going to hit second enter so I can bring up my last equation. I'm going to type in 8.5, and we get 3.9 times 3. Okay, so type this in my calculator, and we get 3.9 times 3 plus 8.4 times 3 plus 8.4 times 3 plus 3.9 times 3. And we get 73.8. So this is roughly about 73.8. And we already calculated this in a before lesson, and we were getting about 72. So now we're overestimating these areas. Even when we did, with the right endpoints, we still got an underestimation. So this is closer than this one, but it's still not very good. So we know how to get the most precise one, and that's adding more and more rectangles. Okay. So example 7 says estimate the definite integral from 1 to 9 of 0.2 x squared minus 2x plus 1.8 dx using 4 rectangles, right endpoints. What do you notice about your answer? So we're going from 1 to 9. So from 1 to 9. And we want to find the area under the curve. So we know definite integrals gives us the area under the curve and the x-axis, or the area between the curve and the x-axis, I should say. Okay, so we want this area maybe not so much over it. I was using a highlighter tool that, there we go. That's a little bit better. So we're going to use right endpoints. And so I'm going to go to the biggest number, my right-hand side of the curve, and I'm going to build rectangles back. Our delta x is still 3 because we're using 4 rectangles. Oh, maybe not. We did use a different curve, so let's actually calculate that. We have 9 minus 1 divided by 4. which is 2. So look at me jumping ahead. We don't want to do that. So our delta x is our biggest number minus the smallest number divided by how many rectangles we have. Okay, and so we want to find the area using right endpoint. So I'm going to start at 9 and I'm going to move down 2. So 1, 2. I'm just going to kind of build the bases like I did before. And then I'm going to start at 7 and I'm going to go down 2. Start at 5 and go down 2. And then start at 3 and go down 2. Okay. And I'm using right endpoints. So my first rectangle that I'm going to look at is my function at 9. And the height of this is just 0. So I'm just going to leave my straight little line here. And then my next rectangle, my pink one, I'm going to start at 7 and go down to the curve and go over 2 and go back to the x-axis. So plus f evaluate at 7, delta x. And then I am going to look at my function starting at 5. Go to the curve at 5. Go over 2. And then go back to the x-axis. So the area of that rectangle is f evaluate at 5 times delta x. Okay, in my last rectangle, I'm going to start at x equals 3. So f evaluated at 3 gives me the height of my curve. And then I'm going to go down 2. And I get this area right here. So delta x. Okay, so I want to evaluate my curve at each of these at 9, 7, 5, and 3. So I get the heights of my rectangles. I'm just going to go into y equals. And I'm going to type in 0.2 x squared minus 2x plus 1.8. And I'm going to go into my table so that I can see what is my function at 9, what is my function at 7, what is my function at 5, what is my function at 3. So second graph. And the first one we're looking at is 9. And the height of this is 0. So I get 0 times 2. I wanted to say 3 again. We've been doing this for both these videos. And then at 7, my curve is at negative 2.4 times 2. Plus at 5, I get negative 3.2 times 2. And then at 3, my curve is at negative 2.4 times 2. Okay, and so when we add these all together, when we multiply this out and add them together, we get 0 times 2 plus negative 2.4 times 2 plus negative 3.2 times 2 plus negative 2.4 times 2. And I still want to say 3, but it is 2. And we get negative 16. Okay, my question asks, what do you notice about your answer? And the biggest thing is that you want to notice that it's negative. So the estimate of the definite integral where the curve is below the x-axis gives us a negative answer. So that negative is giving a position. So the area, the estimate for the area is 16. The estimate for the integral is negative 16 because when we're looking at definite integrals, when we're looking at area below the x-axis, we give a negative to give a position. Okay. So question 8 says Rosa estimates that the integral from 0 to 4 of 0.5 x squared minus 3 dx is 3 using right triangles, 4 rectangles with right endpoints. I'm sorry, guys. I promise I can read. But let's try it again. Rosa estimates that the integral from 0 to 4 of 0.5 x squared minus 3 dx is 3 by using 4 rectangles with right endpoints. If she wants a more precise estimate, what can she do? Okay, so she went from 0 to 4. So from 0 to 4, and she estimated underneath this curve in the x-axis. That's what our definite integral does, is it gives the area under the curve and the x-axis. And it also kind of tells position. And she got 3 units. But we can see that's probably not the best estimate. So if she wants a more precise estimate, what can she do? And I know you're probably saying, well, why doesn't she just take the integral? We can do that. We can do that with our calculators. We can use fundamental theorem or calculus, but we just want to estimate. So what we said before is we talked about what is our calculator doing when we're doing this. And we got the precise area under the curve. But the thing is, when we add more and more rectangles, we become more and more precise. So something that Rosa could do is add more and more rectangles. Okay, guys. That's all I have for you today. This was just kind of tying up any loose ends for Riemann sums. Really, the thing about them is you can do left endpoints, you can right endpoints, you can midpoints, you can do multiple rectangles, but ultimately it's giving you, you're finding rectangles and you're finding the area of them and adding them up. All right, guys, if you have any questions, feel free to email me and let me know.